The most I can get without lifting my finger is 3 carbons in a row. That makes that a 3-carbon chain, or propane. But it's not just a 3-carbon chain. Sticking off of that 3-carbon chain is a 1-carbon side group or substituent. Since it's only 1 carbon, we're going to call it a methyl group. And so this compound, its most complete name is 2-methylpropane. They're both C4H10, but they have slightly different properties. The one on the top has a slightly higher boiling point, a slightly higher melting point. Now they both are nonpolar, insoluble in water, both are flammable. Yes?
Where did 2 come from?
In my 3-carbon propane, what that's telling me is which carbon in the propane is the methyl group attached to. The first, the second, and the third. Now in this case, you really can get away without using the 2 in this one. Because if I stuck it on carbon 1, that just extends it into a 4-carbon chain. Same if I put it on carbon 3. But just to be consistent, don't use the number whenever we can. The only big exception is we won't use it with rings. But we had a carbon with 3 hydrogens side group. That's a methyl group. If you see a CH3, CH2 connected to your group, a 2-carbon fragment connected to your main chain, it's an ethyl. 3 carbons, you actually have 2 choices. You have propyl or isopropyl. The difference is which carbon in your side chain has the connection to your parent or main chain. In the actual propyl side chain, it's the carbon at one end that's then attached to your parent chain. In the isopropyl, the connection is through the middle carbon. We also could have halogens, fluoro, chloro, bromo, iodo. Now, if you have both chlorines and fluorines replacing hydrogens on your alkane, you could end up with a chlorofluorocarbon, a CFC. Compounds used as historically as refrigerants as well as propellants in aerosol cans. Big problem is they float up into the atmosphere and react with the ozone layer. Or some halogenated alkanes are also anesthetics. One of the most commonly used anesthetics these days is one called halothane, which is simply a alkane with several halogens attached to it. I believe there's even a discussion of it in one of the boxes in the textbook. So let's talk about naming a basic alkane. Our primary system for naming most organic compounds, this will be true for the alkanes as well as the other classes of compounds we'll eventually discuss. For those of you taking 122, first thing you want to do is you want to identify the main or parent chain or the main or parent ring. In your structure, find the longest continuous chain or the largest ring of carbons. And that's going to be your base name for your compound. It's actually going to be the part that comes at the very end of the name. If you have a 5-carbon chain, then you'll name it as a pent. If it's single bonds, it'll be pentane. If you have a 7-carbon chain, it'll be heptane. If you have a 4-carbon chain, butane. But once you identify the parent chain, then you also got to identify and name anything stuck to that parent chain other than hydrogens. Any carbon groups that aren't actually part of the parent chain, any halogens, as well as in later discussions, other what are called functional groups. For the substituents, you'll list them before the name of the parent chain. Like I listed methyl before the propane. If you have more than one, if they're two different ones, list them alphabetically. So if I have a methyl and a chloro, I'll actually list chloro before methyl because C comes before M. If you have more than one of an identical type of side chain, two chlorines or two methyl groups or two bromines or three chlorines, then you can use a numerical prefix like we used in naming inorganic compounds, di, tri, tetra, and so forth. But when you are trying to decide how to alphabetically list them, don't use the letter from the prefix di, tri, etc. in your alphabetizing. Use the actual first letter of the name of the side chain. So dimethyl would still be alphabetized based on the letter M from methyl. And each one you get a number. Basic role is we want